Again, we say by applying the inherent safer design, we have four main approach. We're talking about the first and second. Now we will talk about the third approach, is to moderate or reduce the strength of an effect, and this applying by separate the plant location from potential impacted people, evacuation point, and emergency response facilities. So I mean to make a safe distance between the plant and the people. At this, for this point or for this disaster, the plant is near to the railway and near to the community. So it should take in a safe distance between them. Fourth approach is to eliminate unnecessary complexity to reduce risk human error. For your information, there is no consideration to be taken in the safeguard and precaution in process safety analysis study. You cannot take a precaution depending on the human intervention in the process safety. It's different between the occupational safety. In the occupational safety, you are depending on the human culture. But in the process safety, you cannot take the safeguard by human intervention or the precaution by human intervention. In this page, we will study the process hazard analysis. And this study will be described in details in 3 or 4 presentations later, including hazard study, LUBA study, also other study like PUTAI and hazard study. Back again to our study, and what is the relation between process hazard analysis with the Bhopal disaster? Actually, we found the hazard assessment had not been highlighted. Look at this figure. To making analysis for process hazard, we need to make a risk assessment. I mean to identify the risk. Then make implementations about the planning, collect relevant data, then conduct facility walkthrough. Okay. But a comprehensive process hazard analysis must at least address process hazard engineering and administrative control, consequence of deviations, and step required to correct or avoid deviation. The following lesson learned in pre-startup safety review. Pre-startup safety review. And we can say PSSR, where it is a way to identify, evaluate, and control issue proactively before an activity is given the permission to proceed. So it evaluate and control issues proactively before activity is given the permission to proceed. In PSSR, shall be confirmed that the period to the operation of critical activities such as equipment are in accordance with premise design specification. We have 3 figures here. We will show this is a table is related to ensure that the equipment in good condition or is suitable for use, or the design specification is good to be used. Also, adequate safety, operating, maintenance, and emergency procedures are in plan. And in this file, we will show the table of emergency shutdown. And also, there is another schedule for emergency plan and emergency response. In PSSR, we provide a study before the job take a permission to be done. Finally, training of each employee involved in an operational has been completed. Finally, also the PSSR will discuss later in separate presentation in details, including all the checklists and procedures on it. Employee participation. As a part of an economy drive, the period of safety training on site was reduced from 6 months to 15 days. Look at this culture. Also, the training is playing important way for enhancing the safety culture and complete the competency of the attendants. Also, the manpower in safety and maintenance was also cut down, intensively to save costs. These reasons is enough to affect the performance of operator and let him mistake. Here, as you show that the errors or the mistakes of operator, as he cannot reading the pressure gauge, or he assumed the faulty of the pressure gauge. This is because he is non-competency. As you see, the organization or the plant culture is too much poor. There is no any employee participation at all. In the last of this session, we will discuss the importance of employee participation and how they participate. The mechanical integrity program is one of the most important learning outcomes from the Bhopal disaster. As we should ensure the design, installation, and maintenance of equipment are fit for use from when they are fabricated to their return. And the maintenance the mechanical integrity program involves three approaches. As you see, three phases. First, plan and implementing preventing, predictive, proactive, and corrective maintenance, PM and CM. Corrective maintenance procedure to maintain equipment integrity. Secondly, provide proper training. This is be written in the phase, in the personal qualification and phase 3. But we can define as a secondary. Provide proper training to each worker in terms of process overview, hazardous, and maintenance procedure. Finally, inspect, test, correct, and record any defect that are outside acceptable limit on a timely manner. Sorry. This is two figure. This is the original MIC storage tank P&ID, and this is the alternative. Okay. In the original P&ID shows the MIC storage tank design. Here, the MIC storage tank design. The MIC produced at the factory was stored in two stainless steel storage tanks, designated as a tank 610 and 611. An identical tank 619 received containment material from either tank 610 and 611 on an emergency basis only. If you remember the figure before, here there is a three tank. 610 and 611 is a storage tank, and 619 is emergency or evacuated tank. Okay. Again, back to the P&ID. An identical tank 619 received containment material from either tank 610 and 611 on an emergency basis only. Okay. This tank provides extra storage volume to allow for an adequate response to potential thermal runaway. Also, a nitrogen blanket was used to maintain slightly pressure inside the MIC storage tank while containing purging MIC vapor into the process vent heater. This tank were equipped with two centrifuge pumps. Each of the pump had specific function. The transfer pump exported stored MIC into derivatives units as need to produce pesticides. As you see, the circulation pump process MIC through a fluorocarbon fast refrigeration system, keep the store MIC temperature near to 0 Celsius to prevent a thermal runaway. This is a circulation pump going to refrigeration unit to make a heat 0 Celsius. Also, the transfer pumps were provided to export MIC into the derivatives unit. There is no record of their use at any time. They didn't use it. Instead of an alternative transfer method here, we're looking here, involved raising the MIC storage tank pressure to at least 40 psi with nitrogen. The red arrows. Under this condition, the MIC should reverse the flow directly into the derivatives until through alternative busway shown in figure. This practice minimizes the potential for transfer pump seal failure to expose factory workers to the lethal process. Leading and lagging indicator. Also, one of the learning outcomes from the Bhopal disaster. Also, it will be discussed in details later, called KPI, key performance indicator. Back again to our lesson learned, we found that the next level of management error in the accident were system-related error, which includes the first is negligence, aerial, minor, MIC leakage, or near miss that could burn and death. Look at this figure. This is the event or accident. Before it's happened, there is some proactive way or methods to prevent the event to happen. This is called a leading indicator. And there is also precaution should be taken to mitigate the consequence. This is called reactive or lagging indicator. So the reasons here is poor management. Secondly, the failure to improve after earlier inspection that reported concern on leak of phosphagen, MIC, and chlorophyll. Also repetcher in pipe work and seal joint and defective gauge and indicator of unsatisfactory instruction method. By applying this methodology, you can measure your performance to prevent the event happening. How you get the consequence, like this dashboard that is being that's happened to comply the key performance indicator. The last learning outcome is emergency response planning, where the corporate management know very well the responsibility of establishing proper emergency response procedure, where it set the layers of defense to reduce the consequence in case of loss of control. But the corporate wasn't follow and not respect the emergency procedure. They not respect emergency procedure while they know the importance of emergency procedure. When they ask them in investigation, they say the emergency procedure is very important, but they ignored to implement the system. For your information, there is 3 main components of emergency response procedure, which include here in the figure, preparedness, mitigation, recovery, and we need response to implement all of them. Let's talk about it in details. The first is preventing this applying by identifying credible scenario and assess operating procedure and safety measure. Second is internal and external communication by share information with site emergency responder and neighbor community. Like talking with, ask ambulance to come, ask fire defense to come. The third is mitigation through internal emergency planning and cooperation with external service. In this figure, we will show they implement a basic cycle plan, do, check, act in emergency response procedure. By set a plan, implement it or do, then it check if the system is going or not, then they, if it need to improve or not. In this page, I highlighted the reference of the Bhopal disaster. You can check this reference and you will get more details about this disaster. Here, by looking to figure, we will find that the process safety management set the proactive barriers to major incidents. As the process safety management set the layers of protection and safeguarding to reduce the risk to be alarmed, to be accepted. Here is the barrier or layer of protection. Here is the hazards, and this barrier is set to prevent the event to be happen. And he defined the holes as the weakness point. If it passing through these holes, the consequence may be raised. So we need to set other protection here to mitigate the consequence. Okay. As you see in this figure, there is a 4 pillars for safe plant and site and for process safety management, which is consists of committee to process safety, understand hazards and risk, manage risk, learn from experience. Learn from experience, learn from incident, gain experience to prevent repeated again, to prevent the accident to repeat it again in your plan. This is an assignment. This is also another disasters in 1988. It's called Viper Alpha oil rig disaster, where the consequence here is 10% loss of North Sea oil and gas production and 1 billion loss. So the question here, what is the immediate and root cause of this disaster? Please show the video, and my recommendation, show the CSP video investigation about the Viper Alpha before you going to answer these 2 questions. This is the reference of our presentation from NEBUSH, from Central of Chemical Process, from CSP and SP, from WISE Global Training, from offshore installation, from remotely operated shutoff valve. Thanks a lot for any question and any open discussion. I'm here with you. In the next session, before I again the question, in the next section, inshallah, we will talking about process safety leadership and the management of process risk. We will talking in details about the process safety leadership, organization learning, worker engagement, and risk management, like hazard and risk assessment. Thanks for your attention.